my dear students. Welcome to the second class on second order derivative. In the first class, we learned the various cases which were essential for us to solve questions on second order derivative. Today, we are going to solve some IAC questions. So, as you can see, I have taken this question from Sulandan Science Avidasa. This is page number 236. This is question number 7, subdivision 2. This had come in the year IAC 2013. So let us solve it. So you are going to get 4 marks for this particular problem. So remember the method, the steps which I taught you. Is that clear? So let us begin. So you can see in the question, you see d2y by dx2 means I have to differentiate the function 2 times. So I start by writing differentiating with respect to x. What's the differentiation of y? It is dy by dx. Now look at this. The powers are constant. Does this remind you of something? If the powers are constant, the base has to be x. So we assume this part as x. So x squared. So this becomes 2 cot inverse x. 2 comes in front, 2 minus 1 is 1, but this is just an assumption. So d by dx of cot inverse x. Next, dy by dx equal to 2 cot inverse x. Can anyone tell me what's the differential of cot inverse x? Tan and cot. What's the differential of tan? It is 1 divided by 1 plus x squared. And what's the differential of cot? It is the same thing, that is 1 divided by 1 plus x squared. It's just that there's a minus sign. So, what are you getting dy by dx to be? You are getting dy by dx to be minus 2 cot inverse x divided by 1 plus x squared. So, this is the first part. So, I hope it's clear. So, the only difficult part out here is I have differentiated the function 2 times. Number 1, if the powers are constant, the base has to be x, so 2 comes in front. The second one, the differentiation of cot inverse x. Now, moving on, look at this. Remember what I told you last class? This is very important. If I differentiate the function one more time, I have to use quotient rule. So I don't want to make the solution difficult. So what's the technique which I taught you? You are going to convert quotient rule into product rule. So what am I going to do with this? I'm going to take it to the numerator. So 1 plus x squared dy by dx equal to minus 2 cot inverse x. Now we differentiate. So what do I write? Again differentiating with respect to x. Now this step is very important, everyone. Now as you can see, there's a multiplication sign. So this becomes your u and this becomes your v. So what is product rule? Can you tell me? It is u d by dx of v, that is dy by dx, plus v, that means dy by dx, into d by dx of u. What is u? 1 plus x squared. If you use differentiation on the left, you need to differentiate the right also. So minus 2 is a constant, comes out. Can you tell me what's the differentiation of cot inverse x? For those of you who don't know the differentiation of cot inverse x, I have already given you the formula when I did inverse functions, but still it is minus 1 divided by 1 plus x squared. If it is tan, the negative sign vanishes. That's it. Okay? So, minus 2 as it is, and what is the differentiation of cot inverse x? It is minus 1 divided by 1 plus x squared. So, I hope no problem till here. So, I will just rub this. Next, now we just continue from this step. 1 plus x squared as it is. What's the differentiation of dy by dx? It is d2y by dx2, second order derivative, plus dy by dx as it is, dy by dx as it is, dy by dx as it is. Differentiation of 1 is 0. Differentiation of x square is 2x. 2x equal to minus into minus is plus, 2 ones are 2 divided by 1 plus x square. Is that clear? Now what is going to happen to this 1 plus x square? You multiply it to the left. That means this side. But since there is a plus sign, you have to multiply it 2 times. So what do you get? 1 plus x squared whole square d2y by dx2. One thing I forgot to tell you, there is a square that is missing in the book. So please make it a point that you rectify it. Plus 2x is already there. So 1 plus x square into 2x will become 2x into 1 plus x square dy by dx equal to 2. Isn't this what you are supposed to prove? So just go through it. So let me explain case 2 one more time. Every time you get a question on second order derivative, a function will be given, differentiate the function once, you will get a fraction. If you get a fraction, then you are not going to differentiate one more time because we don't want to use quotient rule. We want to make the solution simple. So what do? We convert quotient rule into product rule. So when you convert quotient rule into product rule, then we use product rule on the left hand side and get what has been asked in the question. So this one was ISC 2013. Now you can try a similar type of question, question number 17 subdivision 1 for homework. Question number 17 subdivision 1 for homework. It is tan. Now let me do question number 16 subdivision 1. Question number 16 subdivision 1. If this is 16 subdivision 1. 16 subdivision 1. If y equal to log open bracket x plus under root x square plus a square, prove that a square plus x square y2. What is y2? What is y2? Second order derivative d2y by dx2 plus xy1 equal to 0. Plus xy1 equal to 0. So this is what you are supposed to prove. So let us do it together. Okay, come on. Yes, some of you have joined. Good. Help me differentiate this. Differentiating with respect to x. What's the differentiation of y? dy by dx is a standard of composite. Log should always be with x. Very good. That's why the basics were very important. That's why I did a lot of class on basics of derivative. So log should always be with x. So I assume this part. What's the difference of log x? It is 1 by x. But this is just an assumption. So d by dx of x plus under root x square plus a square. So next dy by dx as it is 1 divided by x plus under root x square plus a square. Differentiation of x is 1 plus, again, is the standard of composite. Root should always be with x because the differentiation of root x is, what's the differentiation of root x? It is 1 by 2 root x, isn't it? So I can use the formula only if there is x inside the root, but this is something else. So what do? I assume. So root x is what? 1 by 2 root x, but this is just an assumption. So instead of writing d by dx, let me differentiate directly. Differentiation of x square is 2x, a square is a constant. So 2 and 2 gets cancelled. So please tell me what is left. So dy by dx equal to 1 divided by x plus under root x square plus a square. What is the LCM? The LCM is root x square plus a square. There is nothing out here. So root x square plus a square plus x. So you can see the numerator and the denominator is same. So we have come to the first step, that is, what's the value of dy by dx? It is 1 divided by under root x square plus a square. Is that clear? So you can just pause the video for a second and take the screenshot of it and you can copy it in your copy. Is that clear? Okay. Now tell me, is this case 1 or case 2? It is case 2. Very good. Why? Because if you differentiate one more time, you are going to use quotient rule, and we don't want that to happen because quotient rule is difficult. So what do? What was the technique which I taught you? I told you to convert quotient rule into product rule, because the moment you get a fraction, then when you differentiate one more time, it becomes complicated. So what do? We take the denominator to the left hand side. So what do you get, tell me? So you get root x square plus a square dy by dx equal to 1. Now what do? I am gonna differentiate. So this is the only step which is gonna be difficult. Again, differentiating with respect to x. So I am not going to do it directly. I'm going to write down each step so that you all understand it properly. So this is u and this is v. So what is product rule? It is u d by dx of v, that is dy by dx, plus v d by dx of u. U means root x square plus a square equal to and 1. What is the differentiation of 1? It is 0. Differentiation of 1 is 0. Now, moving on, root x square plus a square, differentiation of dy by dx is d2y by dx2 plus dy by dx as it is. What should be inside the root x? So again the same process which we have done in the previous case. Root x, it is 1 by 2 root x, but this is just an assumption. Differentiation of x square is 2x. So 2 and 2 gets cancelled. So what is the LCM of these two? LCM of these two, it is root x square plus a square. So what do I get? There's nothing out here, so root into root, the square root vanishes, so you get x square plus a square d2y by dx2 plus the denominator and the LCM is same, so whatever is the numerator you just have to write that. What is that? X dy by dx. And one thing please keep in mind, we don't take the differential coefficient when we are taking the LCM equal to 0. So this entire thing goes up. So what you get when this entire thing, the LCM goes up? So root x square plus a square into 0 is 0. So what is your final answer? X square plus a square d2y by dx2 plus x dy by dx equal to 0. And if you want to write it in notation form, then d2y by dx2 is y2, dy by dx is y1 equal to 0. HP hence proved. So this is how you solve the question. Is that clear? Okay. Now, just I want you to understand this solution one more time. So what we have done is we have applied two formulas out here. Number one, differentiation of log, and the second one, differentiation of root. Differentiation of root. Now, let me do another question, similar ISC type question. Okay. Another important question for you all. Yes. Question number 19. Question number 19 says, if y equal to sine open bracket 2 sine inverse x, sine open bracket 2 sine inverse x, show that 1 minus x square y2 equal to x y1 minus 4y. Now let us use the notation. It's not necessary that you have to use the notations y1 and y2. You can substitute later also, but since the question is y1 and y2, let us do it, no problem. So what do I write? Differentiating with respect to x. What's the differentiation of y? It's dy by dx, but let me write down the notation y1. Sine should always be with x. So sine x, what's the differentiation of sine x? It is cos x, but this is just an assumption. So d by dx of 2 sine inverse x. So y1 equal to cos 2 sine inverse x. 2 is a constant. So differentiation of sine inverse x is 1 divided by root 1 minus x squared. So y1 equal to 2 cos 2 sine inverse x divided by root 1 minus x squared. So this is the first part, that is dy by dx. I hope till here no problem. So what do we do next? The same process. What do we do next? We take the denominator to the left hand side. So you get root 1 minus x squared y1 equal to 2 cos 2 sine inverse x. Now this is u and this is v. So again differentiating with respect to x. So what do I get? Tell me. U d by dx of y1 plus y1 d by dx of root 1 minus x squared equal to 2 as it is. Cos should always be with x. So what is the differentiation of cos x? It is minus sin x. But this is just an assumption. So d by dx of 2 sine inverse x. So again I have told you this is the only part which might be a bit difficult. So once again, product rule, u into v. So u is root 1 minus x squared d by dx of y1. Now keep y1 constant, differentiate root 1 minus x squared equal to, now again out here, if I differentiate the left and differentiate the right also. So 2 cos as it is, 2 as it is, differentiate of cos x. Differentiate of cos is minus sin x, but this is just an assumption. Okay, I'll just give you some time. You can just pause the video for a second and take the screenshot of it. So as you can see, any question on second order derivative can be done. So 4 marks, you can easily score 4 from this particular topic. The reason why the basics of derivative is important for is basically for this particular chapters. Okay, so moving on, root 1 minus x squared. What's the differentiation of y1? It is y2 plus y1 as it is. Again, look at this. Inside the root, what should you get? X. So root x is 1 by 2 root x. But this is just an assumption. So differentiation of 1 is 0 and x squared is 2x equal to minus 2 sine open bracket 2 sine inverse x. 2 as it is. What's the differentiation of sine inverse x? It is root 1 minus x squared. So root 1 minus x squared y2, 2 and 2 gets cancelled, plus into minus is minus x y1 divided by root 1 minus x squared equal to minus 2 2s are 4 sine 2 sine inverse x divided by root 1 minus x squared. Now what is the LCM of the left hand side? It is root 1 minus x squared. So when we take root 1 minus x squared as the LCM, there is nothing in the denominator, so numerator into the LCM, root and root gets cancelled. So you get 1 minus x squared y2 minus x y1 equal to minus 4. And what is sine to sine inverse x? Instead of that, can I write this as y? I can easily write this as y divided by root 1 minus x squared. So root and root gets cancelled. So what is the final answer? 1 minus x2 y2, negative both that side becomes positive, x y1 minus 4y, hence proof. This is what you're supposed to prove. Okay, you can just copy this. This one was question number 19. So a similar type of question is question number 21. I want you all to try that. Once again, let me tell you what questions you can do at home. 17 subdivision 2 I have done. So I want you all to try question number 16 subdivision 2, 17 subdivision 1. Then you can try 21, question number 21. Is that clear? Okay, now I'm going to do one last question, that is question number 22. It's ISC 2003. So to understand the basics of second order derivative, the questions which I have done, if you do it properly, then you'll have no problems on these type of questions, and I'll be giving you solutions. I'll be sending you PDF files on some more questions of this chapter. So this is going to be our last question from this particular topic. Question number 22. Y equal to e to the power a cos inverse x. Show that 1 minus x squared y2 minus x y1 equal to a square y, and I have to find the value of y2 at x equal to 0. I have to show that the value of y2 at x equal to 0 is a square e to the power a pi by 2. I guess square is missing in your book, so please rectify the question. So let us do it. Come on. So what do I write? Differentiating with respect to x, differentiation of y is y1. E should always be with x, so it's a composite function. So I assume this part as x. What's the difference of e to the power x? It is e to the power x, but this is just an assumption. So d by dx of a cos inverse x. Next, moving on. Y1 equal to e to the power a cos inverse x. A is a constant. What's the differentiation of cos inverse x? In the previous case we did sine and cos are same. 1 divided by root 1 minus x square. It's just that for cos there is a minus sign. So write this properly. Y1 will be minus a dot e to the power a cos inverse x divided by root 1 minus x square. Again, the first step. That means I have differentiated the function once. This is called first order derivative. Now since I have to find y2 means second order derivative, I need to differentiate this one more time. So can you tell me what will be the next step? Yes, very good. So what's going to be my next step? I am going to convert quotient rule into product rule so that the calculation becomes simple. So what do I do with the denominator? I take it to the left hand side. So 1 minus x squared y1 equal to minus a dot e to the power a cos inverse x. Cos inverse x. So now what do? I need to differentiate this. So again, differentiating with respect to x. So again, this becomes your u and this becomes your v. Please tell me product rule one more time. U d by dx of v plus v d by dx of u equal to minus a is a constant. Differentiation of e should always be with x. So e to the power x, but this is just an assumption, a cos inverse x. As I told you, only this step is going to be a bit difficult. Is that clear? So please pause the video and take a screenshot because I'm going to drop this. Is it done? Now the final part, root 1 minus x squared as it is, differentiation of y1 will be y2 plus y as it is, y1 as it is, root should always be with x, you know that, so the differentiation is 1 by 2 root 1 minus x squared, but this is just an assumption, the circle part inside the root, it's 1 minus x squared, so differentiation of 1 is 0 and x squared is 2x, done, equal to minus a e to the power a cos inverse x, a as it is, what's it? A is a constant, so comes out, so differential of cos is 1 by 1 minus x squared with a minus sign. So 2 and 2 gets cancelled. What is the LCM of the left hand side? This root 1 minus x squared. So there's nothing out here, so root and root gets cancelled, so we are left with 1 minus x square y2 plus into minus is minus x y1 equal to minus into minus is plus, a into a is a square e to the power a cos inverse x divided by root 1 minus x square. So this and this gets cancelled. So isn't this what you're supposed to prove? Just see. So 1 minus x square y2 minus x y1 a square. So it's just that instead of e to the power a cos inverse x, they have written y. So this is the first part of the proof. Is that clear? Now look at the second part of the proof. At x equal to 0, put x equal to 0 in this, because y, the value of y is in terms of x. So put the value of y equal to 0 in this equation. So what do you get? 1 minus 0 y2 minus 0 into y1 equal to a square, yes, a square e to the power a cos inverse, the value of x is 0. So 1 minus 0 is 1, 1 into y2 is y2, 0 into y1 is 0 equal to a square e to the power a, and cos inverse 0 is pi by 2. You have learned this in inverse trigonometry. So if I want to remove this cos inverse, then this also has to be cos. So cos 90 is 0, so cos and cos gets cancelled, so pi by 2. Therefore, what is the value of y2? Equal to a square e to the power a pi by 2. So just go through the solution. So with these questions, we have come to the end of this particular chapter, second order derivative. So please don't forget to do the questions which I have given you for homework. I'll be sending you few more questions, important questions, probable questions in PDF file with solutions in it. Thank you so much.